Hello everyone and welcome to the channel. So today in this video we are going to discuss about chemical thermodynamics, and we'll be discussing, we will be revising all the formula and all. So before starting this video, I'd like to share a thing with you guys. This which you are seeing right now is a small notes or a short notes which I always used to make whenever I study. Okay, so I'll suggest you guys, I think it's now time is not that enough, but yet if you are studying right now something, just try to write down it in shorts. And see, I have just make around 11, 12, 13 pages of all physical chemistry important topics. Okay, so these notes or these short notes, this helped me a lot. Okay, and this was, I can say that this was the main reason behind my success in CSI GRF. Okay, so this from this much notes, from I would say around 12 or 13 pages it was around, and it contains thermodynamics, then chemical kinetics, then phase equilibria, then electrochemistry, all the important chapters from physical chemistry. And it gave me around 30 marks, 30 to 40 marks from this notes only, direct questions, because all the things which I used to study, I just write it down in a shortcut manner, so that when the exam approach, just before the exam, I can revise all the things. So I'll just take out, like I was searching for few things, so I got it, so that's why I'm sharing it with you. And today we will be discussing chemical thermodynamics from here only. Okay, so just few points which will, if they help me in the CSIR exam, so I'm sure that it is going to help you all also. Okay, so that's why I'm sharing it with you. So after discussing all the formula and all, we'll be solving questions. Okay, so let's start with the topic. So first thing is like the basic thing, which is different processes and what that process means and what the things are constant in that. First thing is isothermal process. In isothermal process, dt is equals to 0, means change in temperature is 0, means there is no change in temperature remains constant. Then it follows Boyle's law. Okay, and work done by isothermal process is graphically, when you find out work done under in isothermal process, that will be the area under PV curve. Okay, P and means a graph between P and V, so the area under that curve will give you work done in isothermal process. Then delta H is equals to 0, and delta E, or you may denote it by delta U, because both are same only, internal energy, those are all 0. It means enthalpy, change in enthalpy and change in internal energy is 0. Specific heat at constant temperature is maximum in isothermal process. Okay, so these are few points which you should know about isothermal process. Some direct question have been asked in earlier CSIR exams. Then next comes is adiabatic process. As you all know, there is no heat exchange between the system and surrounding, that's why dq is equals to 0 in adiabatic process. Now let's come on to the isobaric process. As its name suggests, iso means same, baric means bar is the unit of pressure, so I have learned like this only. Iso means same, bar means bar is a unit of pressure, so pressure is constant in isobaric process, so dp is equals to 0. Now next comes polytropic process. In polytropic process, dcp is or dcv, both are is equals to 0, and it change in specific heat at constant pressure and specific heat at constant volume, both are 0. Okay, means there is no change in specific heat in polytropic process. Then next is quasi-static process. The system passes through all the equilibrium state, means the system which is all in equilibrium with each other, which passes all through the equilibrium state, are called quasi-static process. Next is isochoric. So isochoric are in which volume is constant. Okay, so dv is equals to 0. And the last is cyclic process. From here one question came. Okay, and the cyclic process, in cyclic process, change in enthalpy and change in internal energy, which you may denote it by dE or du, both is equals to 0. One thing is that in cyclic process, all the state functions are change in its state function, means surface integral of all the state function for a cyclic process is 0. Means if you take a surface integral, okay, if you take a cyclic or a surface integral of any state function, okay, so that will be 0. Okay, means d of state function. Okay, I'll discuss it when I'll be solving questions. Now next is isothermal reversible expansion. Okay, so expansion work means work done during isothermal reversible expansion. Okay, so in that case work done is equals to minus 2.303 nRT log V2 by V1. If you are expressing it in log base 10, if you are expressing it in natural log, then this 2.303 will vanish and it will be minus nRT ln V2 by V1. Okay, if you are expanding from V1 to V2. Okay, if expansion is going from V1 to V2. Now the next is reversible adiabatic expansion. Means like in during adiabatic expansion of ideal gas. So during that PV to the power gamma is constant, or PV is equals to nRT. So you can like it has been like you can replace it with like PV is equals to RT. Okay, so R is constant already, so we have written P is equals to RT by V. So RT by V, so just we have replaced this P with RT by V. Okay, and that V has given here gamma minus 1, and this R is constant, so that's why we are not writing it, because on the other side is constant already. So constant divided by R, that will give you another constant, so that is constant only. Okay, and in one more form, that is T to the power gamma and P to the power 1 minus gamma is equals to constant, where gamma is ratio of Cp and Cv. Cp is specific heat at constant pressure and Cv is specific heat at constant volume. I'll suggest you guys to, like, if you can write it along with me, then it will be beneficial for you. Okay, okay, so the next one is work done by reversible adiabatic process. So work done during reversible adiabatic process is W is equals to 1 by gamma minus 1 P2 V2 minus P1 V1, or W is equals to 1 upon gamma minus 1. We have just replaced PV is equals to RT. Okay, so it will be RT2, and here you will get RT1. R will, we have taken out NR. Okay, for N moles, so we will get T2 minus T1. So 1 by gamma minus 1 nr T2 minus T1. So this is work done by reversible adiabatic expansion. Okay, so the next one is work done in irreversible adiabatic expansion of ideal gas. So for free expansion, work done is 0. So if it is asked that for free expansion of ideal gas under irreversible adiabatic process, so the work done will be 0. Okay, but if the expansion is not free, then work done will be NCV. P external means the external pressure upon P internal into T2 minus T1. Now let's come on to the thermodynamics first law. So the first law of thermodynamics is du is equals to dq plus dw, where du is the change in internal energy, dq is the heat absorbed, and w is the work done. Okay, so this is the first law of thermodynamics. Now for cyclic process, du is equals to 0, for adiabatic process dq is equals to 0, and for isothermal process also du is equals to 0. So you should know all these conditions. Okay, next is the enthalpy or the heat content. So enthalpy is given by dH is equals to du plus pdv. Okay, this is pdv. It is dH is equals to du plus pdv. I hope you all know all the terms. Okay, so I'm not explaining everything. It's just a revision video, so that's why I'm not going in that detail. Okay, so delta H will be positive under endothermic condition and delta H will be negative under exothermic condition. Okay, so these things you should keep in mind. These are very small things, and 2 marks question can be easily asked from anywhere of here. Okay, next is specific heat capacity. So specific heat capacity, the formula is given by C is equals to Q by M delta T. Okay, where C is the specific heat capacity, Q is the heat absorbed by the system. Okay, M is the mass of the like gas, and delta T is the change in temperature. Okay, so you can write it like, if you want, if you are expressing it in molar heat capacity, so C is equals to dQ by dt. That will be for 1 mole. Okay, so molar heat capacity means heat capacity of 1 mole of gas, so that will be dQ by 1 molar of gas. Okay, so that will be dQ by dt. Now at constant volume, heat capacity at constant volume is Cv, and that is equals to du by dt. Okay, du is change in internal energy at constant volume. Okay, so this V denotes that it is heat capacity at constant volume. At constant pressure it will be Cp, and that is given by dH by dt at constant P. Now for real gas, this equation follows that Cp minus Cv is equals to R. This is very well known equation, and this is very important too. Okay, so next is the first thermodynamic equation of a state. The equation is given by del U by del V at constant T is equals to T del P by del T at constant V minus P. This is first thermodynamic equation of a state, and this is the second thermodynamic equation of a state, that is dou H by dou P at constant T is equals to minus T dou V by dou T at constant P plus V. Okay, so these are the two thermodynamic equation of a state. Next is the degree of freedom. So degree of freedom, I think you all know that it is sum of transitional degree of freedom, rotational and vibrational, and this is always equals to 3n. Okay, so this transitional degree of freedom is equals to number of this for all molecules, it is always 3. Okay, so transitional degree of freedom is 3 always, because there are 3 axes x, y and z. For linear molecule and rotational is 2, and for non-linear molecule and rotational is 3. Now the rest you can calculate. Okay, so here I have given one example also for CH4 molecule. Okay, so the next is Joule-Thomson coefficient. The equation says that dt by dp at constant h is equals to minus 1 by cp dh by dp at constant t, where dt by dp at constant h is called Joule-Thomson coefficient. Okay, so question is not directly asked from here, but it could be asked. Okay, so Joule-Thomson coefficient is one of very important topic from thermodynamics. One more is there, Clausius-Clapeyron equation, on which whole your phase equilibrium depends. Okay, so these two are very important top equations. Or you can write it as mu jt is equals to 1 by cp and t del v by del t at constant p minus v. This we have taken from the second thermodynamic equation of a state. Okay, so from here we have put the value of dou h by dou p at constant t over here to get this equation. Okay, so for ideal gas, mu jt is always 0. This you should know. These things you should know. These are the 2 marker questions from where they can ask you. Okay. Now next is the inversion temperature. The temperature at which mu jt means the Joule-Thomson coefficient becomes 0. So that temperature is Ti is equals to 2A upon RB, where A and B are like constant used in the real gas equation. Okay, and R is the gas constant. So this is inversion temperature. Okay, so the next is Carnot cycle, and it's one of the most important topic where every time question has been asked. Okay, so if a particle moves from A to B, then B to C, then C to D, and then from D to A, and like here the change in like Q1 is the okay, so AB and CD is the isothermal and reversible compression and expansion. Okay, so AB is compression and CD is expansion. Then BC and DA are adiabatic reversible compression and expansion. So BC is compression and DA is expansion. Okay, now these P1 V1 and T2 and P2 V2 and T2, all these represent the pressure, volume and temperature at that point. Okay, everywhere. And Q1 is the heat. Okay, so the heat absorbed at this place and in this process, and Q2 is the heat absorbed in this system. Okay, so the total work done which you should know is like this. I have just written for the derivation sake of derivation. Okay, so the total work done is equals to minus R, or if it is n mole, then nR ln of V2 by V1 into T2 minus T1. So this is the total work done during a complete cycle of Carnot cycle. Efficiency is given by eta is equals to minus W total upon Q2, and efficiency is also given by Q2 minus Q1 upon Q2, or 1 plus Q1 upon Q2, and efficiency is also given by 1 minus T1 by T2, or you can write it as T sink upon T source. Okay, so this is sink, temperature of sink, and this is temperature of source. Now there is one more thing called coefficient of performance, that is beta, denoted by beta, and that is equals to QC upon W. QC is the heat absorbed during the process and W is the work done. Now relationship between beta and eta means the coefficient of performance and efficiency, that is given by beta is equals to 1 minus eta upon eta. Okay, now efficiency is like I have already told you, 1 minus T sink upon T source, and this is the equation which is mostly used to solve the questions from Carnot cycle, that is T sink upon Q rejected upon T source upon Q absorbed, means heat rejected and heat absorber has given, or the heat absorbed. Okay, next is the entropy. Entropy is denoted by ds, and that is equals to dq by t. For reversible process, change in entropy is equals to 0. Okay, now entropy change during phase transition. During phase transition, delta S transition is equals to delta H transition upon T transition. That means delta S of fusion is equals to delta H of fusion upon T of fusion. Change in entropy during isothermal process is given by NR ln of V2 by V1, and similarly for isoporic process it is given by NCV ln of T2 by T1. For isobaric process it is given by NCP ln of V2 by V1, and delta S adiabatic means change in during entropy during adiabatic process is 0. Feasibility of a process. So a process is called feasible if du at constant entropy and volume is less than or equal to 0, or ds at constant internal energy and volume is greater than or equal to 0. So these are the conditions for feasibility of a process. Next is the Clausius-Clapeyron equation, that is dp by dt is equal to dq by t v2 minus v1. This will give you relation between pressure, temperature and volume, okay, during expansion or anything. So these are other forms of Clausius-Clapeyron equation. Next is like these are the condition for spontaneous, non-spontaneous process. Okay, so if delta H is negative, delta S is positive, delta G is negative, then it is spontaneous. Otherwise, and rest is like if all the three are negative, then spontaneous. If all three are positive, then it is non-spontaneous. Okay, so this table is very important if they ask about spontaneity of the reaction. Helmholtz free energy. So Helmholtz free energy is given by this equation, d is equals to du minus TdS, or d is equals to minus PdV minus SdT. These are all derived. One more video I have posted. On how to memorize or how to solve that what you call that Maxwell relation. Okay, so for Maxwell relation I have posted a video. You can go to this link and watch that video. Okay, that was like very nice video I have made for learning to understand, to derive, like easy way to understand how to do the Maxwell relation. You don't have to learn. Okay, you can easily derive it. So go to that link and watch that. Now the next is Gibbs free energy. It is given by dg is equals to vdp minus sdt. Other formula for Gibbs free energy are these two. Okay, so the next is Gibbs Helmholtz equation. It is given by dg is equals to delta H minus T delta S at constant temperature. Delta G is equals to delta H minus T delta of delta G by delta T at constant pressure. Okay. The next is delta A is equals to delta U minus T minus dou of delta A by, this is like this is the Helmholtz free energy, and delta G is Gibbs free energy. Delta H is enthalpy. Okay, the next is Nernst-Heat theorem, and it says that if temperature is 0 Kelvin, that is at absolute degree temperature, at absolute 0 degree Kelvin temperature, delta G is equals to delta H, that is, or you can say that limit delta T tends to 0, then delta G is equals to limit delta T tends to 0 delta H. So this is Nernst-Heat theorem. Now the next term is partial molar quantities, and that is chemical potential is given by mu I. Mu is chemical potential is equals to mu naught I plus RT ln P by P naught. Okay, and Gibbs Duhem equation, and next is Gibbs Duhem equation from where question has been asked once. So the Gibbs Duhem equation is sigma of means summation of Ni d mu I means change in chemical potential and product of number of moles. Okay, so this is equals to 0. Now this thing holds for everything, that is, if you replace this chemical potential with enthalpy, then also this will be 0. If you replace it with internal energy, then also 0. If you will replace it with Helmholtz free energy, then also it is 0, but not valid for G. Okay, if you will write NiDGi, then that will not be equal to 0. So this thing you should keep in mind. And one more thing, that delta G is equals to sigma mu I Ni. Okay, so this is also one of the important thing. Because this is not equal to 0, so the Gibbs free energy is equals to sigma of mu I Ni. The mu I is chemical potential and Ni is number of moles. Now there is a relationship between reaction at constant volume and constant pressure. Enthalpy, that is relationship between enthalpy of reaction at constant volume and constant pressure, that is given by Qp is equals to Qv plus P delta V, or Qp is equals to Qv plus nRT. So this much thing, yeah, like this all was a very short thing, very important and very crisp and very short things from the thermodynamics, where from where question can be asked and from where question has been asked. Okay, so probably the questions will be asked from here only in the upcoming exam. So it was just like a revision, and now we will try to solve few questions from previous exams and try to understand how they are solved. Okay, so let's try to solve this question which came in CSIR December 2017 exam for 2 marks. Okay, the question says that the enthalpy is equals to, you are given 4 different options. So enthalpy and the like mu I and I, like recently I like few minutes back we saw that delta G is equals to sigma of mu I Ni. Okay, so we know that delta G, from delta G we can get this term. Now we need to find out relation between enthalpy and delta G. So a very well known equation is delta G is equals to delta H minus T delta S. So if you will write delta H, that will be equal to delta G plus T delta S. T delta S, or you can write Ts over here. So for delta G we'll write this term sigma mu I Ni and plus Ts, so that will be equal to delta H. So the correct option will be option number 2. Okay, so in this way this question has to be solved. The next question is of 4 marks and it came in CSIR December 2017. The question says that the stretching of a rubber band delta G is equals to VdP minus SdT plus FdL. So which of the following relation is true? Now for this question I have solved it in very detail. You can go to this link and watch it. Okay, so I'm not solving it here. You can go to this link and watch this video. This is like I have solved it whole. Okay, so the next question is asked in CSR December 2017 and asks for 4 marks. It says that for 1 mole of an ideal gas undergoes cyclic process ABCDA starting from A through 4 reversible process shown in figure. Total work done in the process is. So you have to identify first thing that, see, at constant volume this process is going on BC. So work done during this process, like you will be having 4 different work done. One will be WAB, one will be WBC, then WCA, and then WDA. Okay, so WAB is isothermal process because it is happening on same temperature. WBC is isochoric process because it is happening on same volume. Then WCD is isothermal again, and WDA is isochoric again. So WBC and WDA, this will be 0 because work done in isochoric process are 0. Okay, so work done during isochoric process is 0 because W is equals to PdV, and since at isochoric process dV is equals to 0, that's why work done will be also 0. So we are left out with only 2 work done. So let's find out WAB. So WAB will be the formula for work done at isothermal process was minus nRT. So it is then at T1, so ln of final upon initial V2 by V1. Then WCD will be minus nRT2, it is happening at T2, ln of V1 by V2. If you want to reverse this, because here we are having V2 by V1, so we just want the things to be symmetrical, so we are reversing it. So we have to remove this minus sign. This will become plus, so it will be nRT2 ln of V2 by V1. Now total work done will be sum of these two. Now when you will add these two, so what will happen? T2 minus T1 you will get. So W total, I'm just writing it down. So NR, it will be T2 minus T1. Why? Because this is positive and T1 is negative. So that's it. And ln of V2 by V1. So this thing you are getting in option number 4. So that's why option number 4 is correct option. N is equals to 1 because it is written that it's for 1 mole. Okay, so in this way this question is to be done. It's very simple question, just came for 4 marks. Okay, so the next thing is the question which came in CSIR June 2017. it came for 2 marks. The question says that the correct statement for any cyclic thermodynamic process is. Now if you remember, when in my notes when I was telling this, during cyclic process du and dh is equals to 0. And one more thing I am telling you, that all the state functions, when you do this for us any cyclic process, all the state functions, integration of all the state function is equals to 0, delta of state function. Okay, so now how you will identify the whether it is a state function or not. So one very simple trick to identify whether a given term is state function or not is that state functions are always expressed in capital letters, like temperature, like volume. Okay, see, volume is expressed in capital letter. This is state function. This is an internal energy. It is also expressed in capital letter. This is heat given to the system, work done. So these are all expressed in small letters. So these are not state functions. This is a state function, so that's why this will be 0 and this is the correct option. So if you know this simple thing, you could have done this question very easily. So it came for 2 marks. Okay, so this question, it came for 4 marks in CSR June 2017, and the question says that the minimum work required by an engine to transfer 5 joule of heat from reservoir at 100 Kelvin to one at 300 Kelvin. That means you are transferring heat from low temperature to higher temperature. That means like usually heat is transferred from higher temperature to lower temperature. That means this is not a heat engine, rather it is a refrigerator. Okay, so it is refrigerator. So for refrigerator, formula will change a little bit. Like for a usual Carnot engine, the formula was eta is equals to 1 minus T is sink upon T source. Okay, T source. This was the formula. Now that means it is T source minus T sink upon T sink. Okay, so it was the formula for normal Carnot engine, but it is refrigerator, so it will change. So for refrigerator, we will be having T2 upon T1 minus T2. So T2 will be always less than T1. So this is for refrigerator. Okay, so that means here T2 is 100 and T1 is 300. Okay, so eta will be, for refrigerator we have 100 upon 300 minus 100, that will give you 100 by 200, that will give you 1 by 2. So the efficiencies come out to be 1 by 2. And similarly for for Carnot engine, efficiency was given by eta is equals to Q by W. Okay, sorry, for Carnot engine it was given by eta is equals to W by Q, but for refrigerator it will be reversed, that is Q by W. So we'll just evaluate both of them. So 1 by 2 is equals to Q by W. W we need to find out, and Q is given 5 joule. So 1 by 2 is equals to 5 upon W. So W will come out to be 10 joule. So like this, it was the correct answer, and option 2 was correct option. Okay, let's move on to the next question. Okay, so the next question from CSR December 2016 for 2 marks. It says that the parameter that always decreases during spontaneous process at constant S and V are. So now from the notes which I gave you, it was written that for a feasibility of process, du at constant S and V is less than 0. That means it is always decreases. Okay, it always decreases. So, and that means for feasible reaction means spontaneous reaction. So for that we'll use that only. So that will give you U. Okay, so U will always decrease during spontaneous process. Okay, so the next question, it says that the partial derivative this is equals to. Now this question is also based on that Maxwell relation, and I have already given the link. You can click on the I button to get the link for that. The video will be on Maxwell relation, how to menoic for simplest menoic for that Maxwell relation. You can watch that video. In that video I have solved this question. Okay, so I am not solving it here. Okay, so the next question, it also came for 4 marks in CSIR December 2016. Okay, the question says that the equation of state for 1 mole of gas is given by P V minus B RT, where B and R are constant, and the value of dH by dP at constant T is. So if you remember, This the term we are getting from the thermodynamic equation, second thermodynamic equation of a state, and the equation was given by dH by dP at constant T is equals to minus T dV by dt at constant P plus V. Okay, so from using this equation we can easily solve this. Okay, so I'll tell you how to solve this question. Okay, so let's take what is given over here. So we have P V minus B is equals to RT. Let's multiply and expand. PV minus PB is equals to RT. Now let's differentiate it with respect to T and taking P as constant. So if P is constant, so P will not be differentiated. dV by dt at constant P minus this whole term, it is, we have taken this as constant and B is already constant, so it will be 0 and R will be like this, and differentiation of T will be 1. Okay, so I'm not telling what differentiation and all is. You should know all these things. Okay, so I'm not going in that detail, so I'm just solving it. So dV by dt at constant P is equals to R by P. So this term we are getting. Now we have to put it over here, okay, in the place of this. So I'm writing it here. So dH by dP at constant T is equals to minus T R by P and plus V. Now let's put the value of P from here. So what we will get from value of P? So P will be equals to RT minus upon V minus V. We'll just put the value of P over here. So it will be minus TR upon RT upon V minus V. So it will go upside. So V minus V and plus V. So this RT and TR will cancel out, and we'll open this bracket using this means multiplying it with minus n. So minus V plus B plus V. So this V and this V are cancelled, so we'll get just B. So the correct option for this whole thing will be option 2, that is B. I know this is some what of mathematics is involved over here. What I have done here, I'm just telling you that I have taken P as constant. That's why P is not differentiated, and differentiating with respect to T. So that's why dt is downward. Okay, so dv, V is not constant, so that is a function that will be differentiated. dv by dt at constant P I have taken constant and B is already given in constant, so both will be 0. Why I have taken P constant? Because here it's mentioned that Pi we have to take constant, that's why. Okay, and differentiation of a term, like if you are differentiating x with respect to x, that will be 1. So that's why if you are differentiating t with respect to t, that will be 1. That's why I haven't shown it here. Okay, so that's what I have done here. Now let's move on to the next question. Okay, so this question is asked in CSIR June 2016, and see, this question can be solved just like we have solved the last question. Okay, the question says that delta H by delta P at constant T has dimension of, which dimension it will be having. So as I told you that from second thermodynamic equation of a state, we have that dH dou H by dou P at constant T is equals to minus T dou V by dou T at constant P plus V. Okay, so we have solved this all and we got this term to be is equals to B. Okay, we got this term is equals to B in the last derivation. I am not deriving it again. You can solve it and get B. Now from the real gas equation we know that P minus A n upon V whole square into V minus B, or you can say NV is equals to nRT. Now if you neglect this n, that is for number of moles, we have V minus B. That means V minus B is the thing which you need to know, because we got B over here. So anything in any formula, okay, anything which is added or subtracted, they will be having the same dimension, then only they can be added or subtracted. This is the very basic thing of physics, like this is taught in class 11th of physics. Okay, so anything which is added or subtracted, that will be having same dimension. That means your B will be having dimension of volume. So if B is having dimension of volume, that means dou H by dou P at constant T is also having dimension of volume. So in this way the correct option for this question will be option 2. Okay, so this is the last question which I am taking for this video. So this question was asked in CSIR June 2016 for 4 marks, and this was a little bit a trick question. Now everything was simple only. The question says that the figure describe how a Carnot engine works. It starts from adiabatic compression step denoted by. So you have to find out the adiabatic compression step. So if you know the diagram for the Carnot engine, which I showed you before. It was having like this, so A B C D, it was like that, and like A B C D, it was like that. Okay, so here A B, okay, so these were the temperatures T1 and T2, and these were the volumes V1 and V2. Okay, so V1 and V2. Okay, so sorry, V2. So AB and CD, these were isothermal process, isothermal, and this was compression, and this was expansion. Okay, and BC and DA were adiabatic process, and this was compression, and this was expansion. Now if you match these two equations, they have changed the number, means the labeling of ABCD. Okay, so here BC was adiabatic compression, which you have to tell here, that correspond to CD. So the correct option for this question will be CD. Okay, so like this they have tried to trick people, and many students have done it wrong. So it's just a matter of how much you are attentive in the question. Okay, so that's all for this video. I tried to solve as many questions as I could, and do tell in the comment section you liked it, the video or not, and I'll try to make few more videos before the exam arrives, so that I can help you more and more, basically from this, the scoring parts, that are these, that I have already uploaded video on electrochemistry, chemical kinetics, and now thermodynamics revision part. Okay, so I'll be making few more videos regarding few more topics. Okay, so that's all. Thank you for watching, and if you haven't subscribed the channel yet, please subscribe it, and do share this video. Write in the comment section you liked it or not, and do like the video. Okay, so thank you for watching. Thank you.